Alright everybody, we're going to talk about twist drills today. This is lap 40 for my students that are following along. Like with all the laps, you need to do the questions in the back and the test. Now the twist drills need to be harder than the material that you're drilling through. So the twist drill is made from a high-speed steel. And I'm referring to this in a machine shop. You can get carbon steel drill bits that would be useful for woodworking. But for a machine shop, you want to use a high-speed steel drill bit. And we're talking about twist drills. There are many other ways to drill material, but we're going to be discussing twist drills only. So the high-speed steel is basically a carbon steel that is alloyed with chromium, tungsten, molybdenum, vanadium, or cobalt. And the properties of these alloys will give the carbon steel wear resistance, heat resistance, and hardness. Before we get into the look and the shape of the twist drills, it's important to understand that there are 4 systems of drill sizes: fractional, number, letter, and metric. And what we have here is a picture of drill size gauges. So we can size drill bits this way. Fractional drills will range from 1/64 of an inch up to 4 inches big. Letter drills will range from a letter A to a letter Z. So they go from smaller to larger. Number drill bits range from a number 1 to a number 97, and they go from larger to smaller, with the smallest one, 97, being only about 6/1000ths of an inch. The photograph that you see right now is a number 80 twist drill. So it's a number drill, a number 80 twist drill, and that measures 13/1000ths of an inch. Very small. Then we have metric drills, and they range from 0.04 millimeter, which is about 1/1000th of an inch, to 80 millimeter, which is just over 3 inches. Now there are different styles of twist drills, and you'll see this in your lap. I've only chosen a few to show you in this video. Core drill, a high helix deep drill. We have a step drill, and an oil hole drill. So the drill bits are fashioned in such a way to do a specific job. The core drill is useful for enlarging punched holes or going through a casting. It has more flutes than a regular twist drill. The high helix drill is meant for drilling deep holes, and it has the high helix so the chips can be fleshed out more easily. The step drill is manufactured so that it does 2 drilling operations in one step. So it would do a pilot hole and a countersink. And the oil hole drill is manufactured in such a way that you can send coolant through the drill body right to the cutting edge. And that will help keep the cutting edge cool on deeper holes, and it will help flush out the chips as well. So the main parts of the twist drill are the shank, the body, and the drill point. On the body, we have a clearance, the flutes, the margin, and the helix angle. Now the flutes are where the chips will flow out away from the cutting edge and out of the hole. The margin is what sizes the hole. If that ever gets wore down, you will have a smaller hole than the drill is specified to drill at. Body clearance is a bit smaller than the margin to allow less friction. And the helix angle, you can purchase drills with different helix angles for drilling through different materials, and this will help flush the chips out from the cutting edge more easily. Now, the web of a twist drill goes through the middle or through the axis of the drill, and it tapers. So the closer to the shank that it is, the wider the web is, and this provides strength to the drill. At the other end, at the point of the drill, it forms the chisel edge. Now, as you sharpen the drill and the drill becomes shorter, the web will become wider, thusly the chisel edge becomes wider, and you may require to thin the chisel edge or thin the web. I'll just back up there a second. You would require to thin the web so that you don't need as much pressure to push that drill into the material. You can imagine that as the web or as the chisel edge gets wider, it will take more force to push it into the material. Here we have a straight shank, and this would go into a common drill press chuck or a chuck that's mounted on your tailstock of a lathe. And here we have Morse taper type drills. And in the previous unit, Unit 39, we talked about drill press accessories and drill accessories, and we talked lots about the Morse taper and how to keep those clean and accurate. Now the point of the drill is what we're mainly going to focus on when we're sharpening, or all that we're going to focus on when we're sharpening it. So we need to know the parts of that point. Not very difficult. 3 parts. Two are repeated. We have 2 lips, 2 heels, and then the chisel edge. And some machinists will call the chisel edge a dead center. I prefer the chisel edge. So 2 heels, 2 lips, and a chisel edge. All right, so here we got the angles. Angels. Just one sec. All right, that's better. Here we got the angles of a common twist drill, a general purpose use twist drill. The point angle is 118 degrees. The lip clearance angle is between 8 and 12 degrees. And the chisel angle, when ground properly, would be between 120 and 135 degrees. Now the point angle will change depending on the hardness of your material. The softer the material, the less of a point angle. So it would maybe go down to 90 degrees. The harder the material, the more of a point angle it would be. So it would go maybe up to 150 degrees. The lip clearance angle may change as well. It generally will be within that range though, regardless of the type of material. You might go down to maybe 6 degrees and up to maybe 16. But that range is usually pretty good for everything. And the chisel angle is determined when you grind the drill bit, whether the lip is held horizontally or on an angle. If you're holding it horizontally, you should end up with it being 120 to 135 degrees. You need to learn how to inspect the drill bit for the angles and for the lip length. Those are 2 very important things to learn when you're sharpening a drill. And here we have a drill gauge that we're using to check the angle and check the length. So what happens if you don't have the same angle on both edges? Well, you're going to have a bad hole. It will drill. It's not going to give you the result that you desire though. Because one edge is going to do all the cutting, or most of the cutting. That's going to cause strain on your drill bit, could cause your drill bit to break. It will cause bell mouth shaped holes. Your drill will dull quicker. So simply you don't want to do that. When you're sharpening your drill bit, you don't want to rush through. You want to make sure those angles are both the same. And then the lip lengths. What happens if our lip lengths on the drill bit are not equal? Well, you're going to end up with a off-center chisel edge, which will result in oversized holes. And if they're bad, enough, like what's illustrated in the picture, you could break the drill. So the angles and the lip lengths, very important. Can't stress that enough. Here we're using a protractor to inspect the chisel angle. Again, the chisel angle will be controlled by how you hold the drill bit when you're grinding it. If the lip is horizontal to the tool rest of the grinder, then you will get this approximately 120 degrees. If it's not, you will get a different angle. Here we're checking the clearance angle with the protractor, and that again should be approximately 8 to 12 degrees. So the lip clearance angle, what happens if we have too much of an angle? Well, you're going to have a very thin cutting edge and it will dull quickly, and you'll have to go and sharpen it sooner. If it's not enough of a clearance angle, the heel will rub behind the cutting edge, and that could cause drill breakage because you need to put more pressure on the drill bit in order to have it cut. So you want that clearance angle to be not too much and not enough. You got to be like Goldilocks and get it just right. Possible causes of drill damage. Well, operator misuse is the main one. Anybody using a tool like this should know how to use it. They should know how to calculate the correct RPM for the material that you're cutting. If you set it too high, it's going to create too much friction and burnout. If you're putting too much force on it or too heavy of a feed, that's going to damage it. As well, if you don't have a heavy enough feed, you're just going to be rubbing that cutting edge, and that's going to damage it as well. So again, be Goldilocks, not too heavy, not too light, get it just right. If you had sharpened it, or if somebody has sharpened it and it hasn't been sharpened correctly, that's going to cause some damage. Not using a cutting oil or a coolant. You know, it's always nice to be cutting with a coolant. If the work's not supported, if you're cutting through a thinner piece of metal and it's not supported well and it springs away or bends, that could cause damage to the drill bit. And probably the most common one is that as the drill gets dull, a person just keeps on using it. And it just gets duller and duller and duller until it comes to the point that it gets really damaged. So you should be maintaining your drill bits, not letting them get super dull. So when is it time to change your drill bit? Well, before it breaks, before it gets seriously damaged. That's the best time before that happens. But you have some indicators of when you need to change it. So if the chips are coming out really blue, or they were coming out spiral shape and now they're coming out broken shaped, or just as small chips, that's an indicator that something needs to be done. If you notice that you have to put more pressure to drill through the same material using the same drill bit, but now you have to put down more pressure, that's an indicator. If the drill bit is changing color, if the drill bit is turning blue, it's time to take it and sharpen it. If the top of the hole is out around, it needs to be looked at. If after you've drilled the hole, you look inside of it and it's got a really poor finish, and you'll be able to compare a good one because you will have used good drills, and you can compare what you know as being a good hole and a poor hole. It's time to change or time to sharpen that drill bit. If the drill chatters when it contacts the work, it should be sharpened. If it's squealing, if the drill bit is squealing, or if it jams in the hole, it should be sharpened. And lastly, an indicator is if you're drilling completely through a workpiece and the bottom of that hole has an excessive burr. It's probably time to sharpen that drill bit. So the steps to sharpen the drill bit, and I love this picture because it has a real nice crack on it, and then it shows us after it's been sharpened, nicely sharpened. So we've got seven steps. First step, of course, is to follow the safety. You're using a grinder. You have to follow the safety. These tools are meant to cut metal. They're going to cut your skin and injure you if you're not following the safety rules. So do not ever wear gloves when you're using a grinder, a pedestal grinder. Okay, if the glove gets caught in there, it will pull your hand in as well. And you do not want that ever to happen to you. Baggy clothes like hoodies and hoodies with strings on them, you're going to be kind of leaning over the pedestal grinder, and you don't want earphone wires or strings from your hoodie ever getting connected in the grinding wheel, caught in the grinding wheel. And the bagginess of the hoodie sleeves are not really desirable either near the rotating wheel. Long hair, you have to have it out of the way. Okay, we're dealing with a tool that's rotating. If your long hair gets caught in that tool while it's rotating, it's going to hurt. It's going to pull that hair out of your scalp. Unforgiving. Okay, so make sure if you're wearing long hair, it is contained. Grinding can be noisy. Ear protection would be a wise thing to use. And of course, you have to have eye protection. Please do not ever use the pedestal grinder without having eye protection on. And lastly here, use your common sense. Behave while you're around these tools. Don't be goofing around when you're near these tools. Even if you're not using them and someone else is, be respectful, give them space, and use your wisdom that you've got. So the second thing that we do after the safety, you want to hold the drill bit near the point, maybe an inch or so, depending on the size of the drill bit and how it's comfortable for you, not right at the end of the point or at the end of the drill. You want to hold that with your left hand, and I'm saying this because I am right-handed, so I want to support the point with my left hand and the shank with my other hand, my right hand, and I want to make sure that the shank is slightly below horizontal. The other thing that I want to make sure of is that the drill bit is on a 59-degree angle to the wheel face, and that the lip is horizontal with the tool rest. Next, you want to bring the lip of the drill against the grinding wheel and slowly lower the drill shank while keeping the drill in contact with the wheel. You want to push the shank straight down, and you're kind of pushing the drill bit forward to keep it in contact. Do not twist the drill. This will give you an undesirable result. It should be a straight down fashion. Then, without changing your hand position, because it is set, and if you take your hands away and move them around to do the other side, you're going to have to reset for the angle on that. If you kind of keep your hands where they are and just rotate the drill bit while it's away from the cutting wheel, the angle will be the same. And this is a nice technique to use to get your drill bits ground a little bit faster and a little bit more accurate too. Then you check it against your drill gauge. Again, you're checking for the angle, the point angle, and the lip length. So you check one side, you rotate the drill 180 degrees, and the angle should be the same, and the lip length should be the same. Typically what I do is I check the angles first on both sides, and then I check the lip lengths on both sides. And they have to be the same. Simple as that. If they're not the same, then back to the grinder and grind them until they are the same. This takes practice. It takes practice. But the payback for this is huge. So just practice and get that payback.